Hello students, hello everyone. In this video, I am going to discuss some circuits like half adder, full adder, encoders and decoders and multiplexers also. And this video is helpful for class 12th students, okay, ISC. So all these circuits I will discuss in this video one by one. So let's start without wasting your and my time. Here we go. See on the screen applications of logic gates. Okay, these are the applications of logic gates. Means these circuits are designed, these circuits are made by using logic gates. Okay, adders, encoders, decoders, and multiplexers. So one by one, I am going to discuss. So first, let's start with adders. Okay, so here we go. Adders are used to perform binary addition. To perform binary addition in computer, adders are used. Adder is an electronic circuit which is used to perform binary addition. There are two types of adders, half adder and full adder. Okay, half adder and full adder. So half adder, it is an electronic circuit which performs binary addition on 2 bits. Okay, and full adder is an electronic circuit which performs binary addition on 3 bits. If you have the question, what is the difference between half adder and full adder, you can write like this. The half adder is an electronic circuit which performs binary addition on 2 bits, and full adder is an electronic circuit which performs binary addition on 3 bits. This is the difference between half adder and full adder. Okay. So if you're getting such question, difference you can write. Now I'm going to discuss half adder. Okay. As I told, it is an electronic circuit which performs binary addition on 2 bits and produces two outputs, sum and carry. There will be two inputs and there will be two outputs. The outputs are sum and carry. The Boolean equations for sum and carry are sum equal to x XOR y, and this symbol, this symbol is for XOR. Sum equal to x XOR y and carry equal to x dot y. Okay. So if you remember these equations for sum and carry, you can draw the circuit easily. You know how? See, sum equal to x XOR y means for this we require one XOR gate, and for carry x dot y means for dot x dot y we require one AND gate. So if you remember this equation, it will be easy for you to draw the logic circuit of half adder. This I am discussing half adder. Okay. So see, here I am going to draw the half adder. So we require two input lines, x, y. I cannot make more straight line than this. Okay, so please, you can draw by scale and all. Here I can draw like this only. So try to understand. Okay, don't think it's a line what ready one day. Okay. Now one XOR gate is required, as I told. For sum we require one XOR gate, and for carry we require one AND gate. Okay, and this x will be joined with this and this. This is for sum, x XOR y. Okay, and this is for carry. AND gate is for carry, and here the output is carry. Sum and carry. Okay, so two inputs x and y, and two outputs sum and carry. The equation for sum was x XOR y, so we have used here XOR gate, and for the carry it was x dot y, so we have used AND gate. Okay, I think the things are clear. So if you remember the Boolean equations of sum and carry, you can draw the circuit easily. It's very easy. And now I'm going to draw the truth table for this. If for each and every circuit, at least prepare how to draw the circuit and how to write the truth table of that. At least these two things you must prepare. What is the definition of that? What is the use of that circuit, and how to draw the logic circuit diagram and the truth table. These three things you should prepare for each and every logical circuits. Okay, here I'm going to draw the truth table. Okay, The two table, how many inputs are there? X and Y are the two inputs. X and Y. These are what? Inputs. Okay, these are what? Inputs. Right, like this. And two outputs are there. Here I'm writing the outputs. Outputs are what? Sum and carry. Two outputs are sum and carry. Don't go through this lines. Okay, you can draw the straight lines. Okay, now here we have two inputs and two outputs. Two inputs are X and Y, and two outputs are sum and carry. Okay. Now you know how to draw the truth table for two inputs. It is like this. You know, 0, 0, 1, 1, 0, 1, 0, 1. This is the easy way to learn to draw the truth table for two inputs. 0, 0, 1, 1, 0, 1, 0, 1. Okay. Now we're going to fill this sum. So if you know binary addition, you can fill it easily. Let me remind you the binary addition. 0 plus 0 is equal to 0, 0 plus 1 is equal to 1, 1 plus 0 equal to 1, and 1 plus 1 is 1, 0. 1 plus 1, we are doing binary addition. So 1 plus 1 is what? 1, 0. And here 0 is sum and 1 will be as carry. 0 will be taken as sum and 1 will be taken as carry. Okay. In case of 1 plus 1. So here 0 plus 0, sum will be 0 and carry will also be 0. There is no carry in 0 plus 0. 0 plus 1, sum will be 1 and carry will be 0. There is no carry here too. Again, the same, 1 plus 0 will be 1, the carry will be 0. Now 1 plus 1, as I told, sum will be 0 and carry will be what? 1. So this is all about half adder circuit to table, and the use of half adder is what? The use of half adder is it is used to perform binary addition on 2 bits. Okay, please remember this. Now full adder. What is full adder? As I told already, it is an electronic circuit which performs binary addition on 3 bits. This is the basic difference I'm telling you. Binary addition on 3 bits. Okay, and produces two outputs, sum and carry. Output is same. And the Boolean equations for sum and carry are, here we have this different equation for sum and carry. The Boolean equation for sum is X XOR Y XOR Z. This symbol, a plus within circle is for XOR. Okay. So X XOR Y XOR Z. The equation for sum. And the equation for carry is X dot Y, Y dot Z and Z dot X. Okay. So let me tell you, for sum we require one XOR gate. For XYZ, there will be three inputs XYZ, and for sum we require one XOR gate. Okay. And now for carry, one AND gate for X dot Y, one AND gate for Y dot Z, and one AND gate for Z dot X. Okay. So these three AND gates, and all that three AND gates will be joined with one OR gate for these plus. Okay. So I'm going to draw the circuit for full adder now. Let's see. So here we require how many inputs? Three inputs are there, X, Y, and Z. So X, Y, and Z. Okay, and for sum we require one XOR gate. So we can draw like this, one XOR gate for X XOR Y XOR Z. Okay, now X will come to here, Y and Z. Okay, X XOR Y XOR Z. This is for sum. And for carry, as I told, for X dot Y we require one AND gate. For y dot z we require one AND gate, and for z dot x we require one AND gate. 3 AND gates are required. Okay, so I'm going to join them. X, Y. First for x dot y. This AND gate is for x dot y. Okay, ignore this ready-made line. Okay, please. Uh, as much I can draw, I am drawing. Now y dot z, y, z. Okay. Now z dot x at last. Third is z, then x. Okay, this is for x dot y AND gate. This AND gate for y dot z, and this AND gate for z dot x. And now all three will be joined with one OR gate for that plus. Okay, and this is finally carry. So if you remember the Boolean equations, you can draw the logic circuit diagram of half adder also easily. Okay, so sum and carry. Now we are going to draw the truth table for this. So here how many inputs? 3 inputs are there: x, y, and z. 3 inputs are here: x, y, z, and these are what? Inputs. Here we can write inputs. Okay, inputs. 3 inputs, and how many outputs? Outputs are same. Here also 2 outputs. Okay, number of outputs are here too same outputs. Outputs are sum and carry. Sum and carry. Okay, so now you know how to draw the truth table for 3 inputs. 4 zeros. Vertically I'm telling 4 zeros, 4 ones, 2 0 2 1, and 0 1 0 1. Here I'm writing like this, as I know the binary codes: 0 0 0, 0 0 1, 0 1 0, 0 1 1, 1 0 0, 1 0 1, 1 1 0, 1 1 1. Okay, vertically I'm telling you 4 0 0 0 0 0 1 1 1 1. Now 2 zeros, 0 0 1 1 0 0 1 1 0 1 0 1 0 1. This is easy way to learn: 4 zeros, 4 ones, 2 0 2 1 2 0 2 1 0 1 0 1 0 1. 3 inputs, 3 variables input truth table. We can draw like this. Okay. Now sum. Now we are going to fill this column sum and carry, sum and carry. So you know that you will perform the same thing, binary addition. So 0 plus 0, everything you know. Here 1 plus 1 plus 1 will be 1 1. Rest you know, this is a new thing here you will get. So I am telling that 1 plus 1 will be 1 1. So 1 will be taken as sum and 1 will be taken as carry. This one will be taken as sum and this one will be taken as carry. So coming to this, x plus y plus z, sum will be 0, binary addition, and carry will also be 0. Here 0 plus 1 will, sum will be 1 and carry will be 0. There will be no carry, so 0. Okay. Then here 0 plus 1 plus 0 will be what? 1. Sum will be 1, carry will be 0. Here 1 plus 1, as I already told, 1 plus 1 is what? 1 0. So 0 will be taken as sum and 1 will be taken as carry. Now 1 plus 0 plus 0 will be 1. Sum will be 1, carry will be 0. Now again 1 plus 0 plus 1. 1 plus 1 will be what? 0 and carry will be 1. Now here again 1 plus 1. So sum will be 0, carry will be 1. Now as I told, 1 plus 1 plus 1, 1 1. So sum will be 1, carry will be 1. Okay. So it's all about full adder. Okay. So please remember this, how to draw the circuit and how to uh, write the truth table and what is the use of that circuit. These things you must know. At least prepare these three things about the any circuit. Okay. And this, you know, half adder, full adder, encoder, decoders, multiplexer. At least one circuit will come in the examination. At least I'm telling you, there might be two circuits. You may have two circuits in examination. Okay, so please prepare all these circuits just not by watching this video. Try to draw it yourself without watching. Practice for drawing. Okay, otherwise you will take too much time in the examination. Okay, now next circuit is encoders. Okay, encoders are electronic circuit which are used to convert from one number system to another number system. Okay, means for example decimal to binary, octal to binary, hexadecimal to binary. These conversions can be done through encoders. Okay, so in your syllabus we have these three: decimal to binary, octal to binary, and hexadecimal to binary. And at least you and here two circuits are very important: binary to decimal and hexadecimal. Sorry, decimal to binary and hexadecimal to binary. Generally, these circuits used to come in the examination. So you can prepare all three. Common things are there. If you get the concept, any one of these three you can draw easily. Okay. So here I am going to discuss binary to decimal to binary. Sorry, decimal to binary encoder. Okay. So decimal to binary encoder, as the name is saying, it is an electronic circuit which converts a signal from decimal to binary number system. Okay, I hope definition is clear. And now here we are going to draw the logic diagram for that. So since we are going to convert decimal to binary, so this table is here, and here I have written the decimal numbers 0 to 9, not 10. Here I am not taking 10. 10 is not there for that. You know, decimal number system, there are 10 digits that are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So 0 to 9, these are the binary codes. You know, this is the binary code of 0. 0 binary code of 0 is 0, 0, 0, 0. The binary code of 1 is 0, 0, 0, 0, 1. And like that, you know, if you, easy way to tell, to learn it, I am telling you, 8 zeros. If you are drawing the truth table for 4 bits, okay, so 8 zeros, you can see 1, 2, 3, 4, 5, 6, 7, 8 zeros, then 8 ones, but here we are going up to 9 only. So 8 zeros, 2 1, then 4 0, 4 1, then again 2 0, 2 0, 2 1, 2 0, 2 1, 2 0, and now 0 1 0 1 0. So this is the binary code of 0, this is the binary code of 1, this is the binary code of 2, then 3, 4, 5, 6, 7, 8, 9, 10. These are the binary codes. Okay. Why I have taken in 4 bits, that's I'm going to tell you. So this is the truth table, and through this we can draw the circuit. So listen, as you know, in binary number system there are 10. How many? There are 10 digits: 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So you have to draw 10 straight lines like this. I'm showing you. Let me show you. 10 straight lines I'm telling you. Please draw by the pencil first, otherwise many overwritings will be there. 10 straight lines for the inputs. 10 input lines, you can say. These are the input lines. So we are going to draw how many? We have to draw 10. It should be straight. Okay. You try to draw the straight lines. Okay. Here I am drawing by this pen tab. So I'm trying to draw the straight lines, but still. Sorry. 1, 2, 3, 4. 1, 2, 3, 4, 5. 10 lines we have to draw. 6, 7, 8, 9. यहाँ draw कर देते हैं. Total 10 lines you have to draw. Anyhow, how many? How many lines? You have to draw the 10 lines. Okay. Okay. Then one thing you can do here. Just a minute. This gap should be there. I'm trying to draw the switch here. Okay, let me show you. Things will be clear. Don't worry. Okay. Now this is for 0, making like switch. Okay, physics में तुम लोगों ने पढ़ा होगा. 0 1. This is 2. This is 3. This is 4. This is a switch. If you press it, the circuit will be completed. This is sorry 4. Then 4. Then 5. Then 6. Then 7, 8, and 9. 0 to 9. So the lines like this. Okay. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. These are input lines. Okay. So number of input lines, on the basis of a number of input lines, we decide how many number of output lines will be there. Okay. So what is the logic? See, how many input lines are here? 10 input lines are here. Okay. So 2 to the power n, this will be the number of output lines, must be greater than or equal to 10. This is the rule. Okay. So you can see 2 to the power 1 is greater than or equal to 10. No. 2 to the power 2 is greater than or equal to 10. No. 2 to the power 3 is greater than or equal to 10. No. So 2 to the power 4, if you see, if you take 2 to the power 4, 2 to the power 4 is greater than or equal to 10. And here, so the number of output lines will be 4. That's why here we have taken this 4 bits. Okay. So 2 to the power 4 is greater than or equal to number of input lines. This is the rule. 2 to the power n, here n is the number of input lines. Okay. So if the number of output lines, here the n is number of output lines. So 2 to the power number of output lines must be greater than or equal to number of input lines. This is number of input lines. This is the rule. So here 2 to the power 4 number of input lines. Here we have 10 input lines. So the number of output lines should be 2 to the power 4 because 2 to the power 4 is greater than 10. So here for that 4 output lines we will draw here vertically we'll draw 4 OR gates. Vertically 4 OR gates will draw. OR gates I'm not able to draw exactly, but you know these are the OR gates. I'm telling you, these are what? These are OR gates. Okay. Okay. Actually, battery was low, so I put in the charge. Now listen. I think charging now. Okay. Now listen. Now here these are what? Output lines. This I'm telling you F0. This is F1, F2, and F3. Okay. In the same sequence you write as you have written in the truth table. In the same sequence you write here too. The sequence of both should be same. This is the main thing. You can take care. Okay, now listen, we are going to join these input and output lines. 10 input lines and 4 output lines. F0, F1, F2, F3 are what? Output lines. We are going to join them. So how to join them? See, see this F0. F0. 8, 0, 0, 0, 0, 0, 0. Means these lines 0, 1, 2, 3, 4, 5, 6, 7 up to this 7. These lines will not be joined with this F0. Only 8 and 9, the values of 8 and 9, for this we have 1, 1. I'm talking about F0, okay. So there only these two, 8 and 9 will be joined with this. Only these two. Okay, I think clear. And now F1, we are going to join the F1, this circuit. So you can see the first 4 lines are 0. So this first 4 lines 0, 1, 2, 3, 4. These, so 0, 1, 2, 3. Up to these first 4 lines will not be joined. Then next 4, for which we have the 1, the value is 1. For the next 4, the value is 1. That next 4 will be joined. So from here, this, and this. Next 4 will be joined. So I'm joining them. It should be straight line. Try to draw the straight line. You can use the scale along and draw by pencil. Okay. Afterwards, please don't forget to finalize it with the pen. because if you draw it by pencil, it must be finalized by pen. Please remember this. See, you can 0 0 0 0 1 1 1 1. Okay, now last two 0, so that last two will not be joined with this F1. Now F2, first two 0, first two 0 means first two lines will not be joined, next two lines will be joined, next two lines will not be joined, next two lines will be joined, like this. So 0 0, leave it, 1 1. So 1 1. Okay, now 0 0, and again 1 and 1. Okay, the next two lines will not be joined. Clear? This is for F2. Now F3. F3 0 1 0 1 means alternative. One first line will not be joined, next line will be joined, next line will not be joined, next line will be joined, like this. 0 1 0 1, you can see like this. So first leave it, second join it, then leave, then join it. Alternate. Alternatively, you will join, then leave it, then join it. Leave it, join. Alternate एक लाइन छोड़ के ज्वाइन करना है, वो छोड़ देते हैं, लास्ट वाला ज्वाइन करना, like this. Okay, this is the way to join. Okay, now we are, our circuit is over, completed. Got it? Now I'm telling you, see, consider this 5. I am taking the example of 5. Working of this, I'm going to explain. If you are pressing this button, this switch, if you are pressing 5, it's in decimal number system. We are going to convert into binary number system. Okay, so 5, if you are pressing it, so you can see this 5 is joined with this line only, with this and this only. If you go through this, it is joined with this only. It is joined with this circuit, this gate and this gate only. See, it is not joined with any other AND gate. Only two AND gates are joined with this. Means for this, these AND gates, sorry, OR gates. For these OR gates only will have 1. For these OR gates only will have 1. Okay. Just a minute. For these OR gates only will have 1. So 1 will be here, 1 will be here. Okay. And for rest will have 0. So you can see 0 1 0 1 is the binary code of what? 5. If you are pressing this, only output 1 will be for this and this OR gate only. For others, it will be 0. So you can see finally we are getting 0 1 0 1. This is the binary code of 5. By this way, this circuit works. So this is about decimal to binary encoders. Okay, listen carefully and please you can go back and revise it again and again. So it's very easy to draw and all. So it is about decimal to binary encoders. In the same manner, if I am going to draw hexadecimal to binary or octal to binary, I am talking about octal to binary. So octal to binary, I will show you. In case of octal to binary number system, you know, in octal number system, there are 8 digits, 0, 1, 2, 3, 4, 5, 6, 7. So 0 to 7, only 0 to 7. So let me show you that also. Okay, in case of octal to binary number system, you know, there are 8 digits in octal number system, 0, 1, 2, 3, 4, 5, 6, 7. So I have written this 0, 1, 2, 3, 4, 5, 6, 7, and these are the binary codes of that. So here again, I'm telling you we have to draw how many 0, 1, 2, 3, 4, 5, 6, 7 means how many input lines? 8 input lines we have to draw. 0, 1, 2, 3, 4, 5, 6, 7. Okay. So number of input lines is 8 here. So as I told, the rule is what? 2 to the power number of input output lines should be greater than or equal to number of input lines. Okay, so 2 to the power 3, you can see 2 to the power 3 is greater than or equal to it is no, 2 to the power 3 is equal to 8. So number of output lines will be 3 here. This is number of input lines is 8 here. So 2 to the power 3 is equal to 8. So number of output lines will be 3. That's why here I have drawn 3 OR gates vertically, and here I have taken 3 bits. So you know how to draw the truth table for 3 bits. 40, 41, then 20, 21, 20, 21, 01, 01, 01. Okay. So this you can draw. Now in the same manner as we have joined in the decimal to binary encoder, in the same manner here also we'll join these inputs and output lines. You know, F1, we have written, sorry, F0, it should be F0, F1, F2. You can write F1, F2, F3 also, doesn't matter. But as just a minute, these things are disturbing. Okay, now listen. Here I'm making 0, then 1, and then 2. F1, F2, F3 writing is also not incorrect as per me. So here F0, I'm going to join this F0 in the same manner. First 4 lines you will not join, next 4 lines you will join. 1, 2, 3, 4. I'm not joining first 4 lines, next 4 lines I will join. Okay, then F1. First 2 lines you will not join, next 2 lines you will join. First 2 lines I am not joining, next 2 lines I will join. Again, next 2 lines I will not join, next 2 lines will be joined. Okay, then here first alternatively 0, 1, 0, 1, 0, 1. I am leaving first, and I'm joining second, then leaving third, then joining fourth, then leaving this, joining this, leaving this, joining this. Okay, so by this way you can join, and this is octal to binary encoder. And in the same manner as when I'm telling you, octal to hexadecimal. I'm not going to draw that. Just try yourself. Octal to hexadecimal. Uh, sorry, hexadecimal to binary. Sorry, hexadecimal to binary. Hexadecimal to binary, you know, in hexadecimal number system, we have 16 digits. How many? 16 digits. So there you will, the digits are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Then for 10, we write capital A. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Then A, B, C, D, E, F. Don't write 10, 11, 12, 13, 14, 15. Write down A, B, C, D, F. Okay. And you know, for A, so how many in hexadecimal number system? How many digits we have? 16 digits we have. So 16 lines will draw. This horizontal 16 lines will draw like this: 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and A, B, C, D, E, F. And that 16. So how many input lines are here? 16. So it must be greater than or equal to number of output lines. So there will be 4 output lines. Okay. So draw that yourself and try to draw that yourself. And here number of input lines means you'll draw 16 horizontal input lines for 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. And there will be 4 output lines as per this rule. And you will draw the truth table like this and join them. Okay, this is all about encoders. I hope the things are clear. Okay, now the next circuit is decoders. So here is the definition of decoders in front of you. You can see it is an electronic circuit sorry, which is used to convert signals from binary to decimal. Okay, decoders are used to convert from binary number system to decimal number system only. Okay, and here we have to learn 2 decoders, 2 cross 4 decoder and 3 cross 8 decoders. Okay, in 2 cross 4 decoders means what? Here 2 is number of input lines and 4 is the number of output lines. Okay, 3 here 2 to the power 3, 2 to the power 2 will be 4, and 2 to the power 3 will be 8. By this way you can learn it. So number of 2 is your number of input lines and 4 is what? Number of output lines, like that. 3 is your input number of input lines and 8 is the number of output lines. Okay. Now I'm going to discuss 2 cross 4 decoders. As I told, it is an electronic circuit which converts 2 bits binary number to decimal. Okay. So here 2 is what? Number of input lines and 4 is what? Number of output lines. And this circuit is here to convert 2 bits binary numbers into decimal. Okay. So for for two inputs, we have taken these X and Y, these two lines as input. And these 4 AND gates we have taken for 4 output lines. Okay. 4 is the number of outputs, 2 is the number of inputs here. So X and Y we have taken for inputs, and F0, F1, F2, F3 we have taken for output. 4 AND gates for the 4 output lines. Okay. Now we are going to join them. How to join these inputs and output lines, that I'm going to tell you. So before that, we have to draw the truth table. Okay. By drawing the truth table, it will be easy to draw the. It is easy to join the inputs and outputs line. So X and Y are the inputs and F0, F1, F2, F3 are the outputs. Okay. So now listen, just first I will fill this truth table, then I will tell you how to join the inputs and output lines. It will be easier for you. So here in case of when the value of X and Y both are 0, only for F0 the output will be 1. For others it will be 0. In case of when the value of X is 0 and Y is 1, in that case, the only for F0 the value will be 0. Sorry, again in case of when the value of X is 0 and Y is 1, only for F1 the value will be 1, output will be 1, and for others it will be 0, 0. In case of when the value of X is 1 and Y is 0, only for F2 the value will be 1, the output will be 1. For others, it will be 0. And in case of when the value of X and Y both are 1, 1, in that case, only for F3, the output will be 1. For others, it will be 0. Okay, in case of this row, only for F0, here only for F1, here only for F2, and here only for F3. Got it? Okay, now we are going to join them by the help of this truth table. So when X and Y both are 0, so as per this row, we are going to join the F0. As per this row, using this row, we are going to join the F0. So here, X and Y both will have two part, X1 without NOT and another with NOT. This, this is NOT gate. And here also we have to draw this NOT gate. Okay, two parts each input line will have. Now F0, we are going to join this F0 by the help of this line. Okay, so how to draw? Here since both X and Y both are 0, 0, both are what? 0, 0 in this row. So F0 will be joined with NOT line of each. Means X, the NOT line of X will be joined with this and NOT line of Y will be joined with this. Means if both are 0, 0, we will use the line which has NOT gate. Okay, and if it is 1, we will use the line which has no NOT gate. This is the rule. Now as for F0, using this row, we are going to join F1. So here X is 0. In case of this AND gate, we are going to join using this row. Here X is 0. So we will use the line which has NOT of X since it is 0. And Y is 1. So we will join, we'll use the line of Y which has no NOT gate, this line. Okay. Now finally F2. As per this row, using this row, we are going to join F2. So here X is 1. The value of X is 1. So the line which has no NOT gate of X will be used here. And the Y is 0. So the line which has NOT gate of Y will be used here. I think things are clear. Now F3, as per this row, both are 1, 1. So X, the line which has no NOT gate will be of X will be used here. The line which has no NOT gate of Y will be used here. And by this way, we can draw the 2 cross 4 decoder. I think clear. 2 cross 4 decoder. So listen, I'm going to show you the working of this. Consider if it is 0, 0, the value of X is 0, the inputs are 0, 0. See, think about this line. If we'll go through this, see, I'm going to show you. If the X and Y both are 0, 0, only for this you will have 1. For others, you will have 0. Sure. See, this output will come. I'm going to show you. See, and if you're getting 1 for this gate only, it means this is the binary code of 0. If you're getting 1 for this gate only, if you're getting 1 for this gate only, it means that is the binary code of 1. If you're getting 1 for this gate only, then that is the binary code of 2. And if you're getting 1 for this last gate only, then that is the binary code of 3. This is the rule. Okay, this is the working of this circuit. Sorry. So listen, I'm going to show you if both are 0, 0. So in that case, you will get 1 for F0 only. For others, it will be 0. I'm showing you. See, see this line. 0, 0 is coming through this NOT line. This 0 is coming through this NOT line. So 0 will be what? 1. And here also this 0 is coming through this NOT line. Here. So this will also be, this is what? 1. 0 will become 1. Not 0. If it is going through NOT gate, it will become 1. So both are 1. So 1 and 1 will be what? 1. You know the AND gate. If any one of the input is 0, the output will be 0. So here both have 1, so output will be 1. Now see this for this. It is coming directly, it is coming through NOT gate. See this, it is coming through NOT gate. So 0 will become 1. And see for Y, it is coming directly. So it will be 0. So 1 and 0 will be what? 0. And in same manner, you can check all each and every AND gate. For others, you will what? 0 only. Okay. If it is, consider I am taking this line F1. So if it is 0 and Y is 1, in that case, only for this you will have 1. For others, it will be 0. In the same manner, you can go through a NOT gate and AND gate. If you go through the outputs, you will get 0, 1 for this only. For others, it will be 0. Means if you are getting 1 for this gate only, it means this is the binary code of 1. As you know, 0, 1 is the binary code of 1. So by this way, this circuit is converting 2 bits binary number to decimal. If you are getting 1 output 1 for this, means 1 is the decimal number system. In decimal number system, if you are getting for this, means we have converted that into 2 in decimal number system. So this is the working. Working you might have to explain. It's rare, but basically you must know how to draw the circuit and how to write this truth table. Okay. In the same manner, we can draw the 3 cross 8 decoders. Okay, 3 cross 8 decoder means there will be 3 lines like this X, Y, Z. Okay, X, Y, Z, 3 lines like this. And how many output lines? 8 output lines, F0, F1, F2, F3, F4, F5, F6, F7, 8 AND gates will draw for the output lines. Okay, and then this circuit will be there. I'm going to show you. Okay, so that will be 3 cross 8 decoder which I'm going to draw now. So in case of 3 cross 8 decoder, we require 3 input lines like this X, Y, Z with NOT and without NOT each, and 8 AND gates for 8 output lines F0, F1, F2, F3, F4, F5 and F6, F7. Okay, then this truth table is there, and same thing in case of this line, first row only for F0 the output will be 1, for others it will be 0. Here for this F1 will be 1, for others it will be 0. And here in case of this, only for this F2 will be 1, for others it will be 0. And here only for F3, for others it will be 0. And here for this line, 0 0 0 0 1 for f, and for others will be 0. And in case of this, only for this will be 1, but for others it will be 0. Draw it properly. Here actually writing with the pen tab is little difficult. Now 1 1 0 for this, only for this you will have 1, for others you will have 0. And at last, only for last one you will have 1, for others it will be 0 0 0 0. Okay, so 0. Okay, now we are going to fill it. Now we are going to join the same thing. If it is as per this, we'll join F0. As per this, we'll join F1. So 0 0 0, all are zeros, so we'll join with the not lines of each X. Not lines, we're taking not lines of each because they are zeros. Now here 0 0 1. So 0 0 1. Okay. Now it is 0 1 0. So 0 for 0 take not line. Okay. 0 1 0. Okay. Now then 1 0 0. So 1 0 and 0. We're taking 0 0 not and 1 without not line. For 1 without not line. Now 1 0 1. So 1 0 1. Then 1 1 0. So 1 1 0. Okay, join it properly. थोड़ा सा यहाँ पे circuit गड़बड़ जा रहा है. 1 1 0. Okay, you can use pencil and scale for better good quality picture. Okay, then F6. Just a minute, some mistakes are there. 0 1 1. Here for F4 we have 1 0 0. F0 F1 F2 F3 F4. For F4 we'll have 1 0 0. So 1 0 0. Okay, now F5 1 0 1. So 1 0 1. Now F6 1 1 0. And for F7 the last line 1 1 1. So all without not line 1 1 and 1. Okay, I think the things are clear. So this is the way to draw the 3 cross 8 decoders. This concept is same. Try to understand it and don't think कि सर ने कितना गंदा drawing बनाया. It's writing by pen tab is little difficult for me. So by the way, I think the things are clear. I have made everything clear to understand. So uh, this is about all about 3 cross 8 decoders. Only these two decoders are in syllabus, 2 cross 4 and 3 cross 8. Again, I'm telling you, please, the half adder, full adder, encoders, decoders, and multiplexers. Prepare all these circuits which I'm providing through this video. In one video, you'll have all these circuits. So please prepare it and don't watch this video. Try to make yourself. Then it will be better. You will learn how to draw. By watching, you can think, हाँ ऐसे हो रहा है. But if when you draw it, no, it will be more clear for you. So practice by drawing these circuits. Okay. Now the next circuit is multiplexer. See one correction here. This will be joined to this line. 1 1 1. Okay, this line. This correction here. So this is all about 3 cross 8 decoder. Now I'm going to discuss the next circuit, that is what? Multiplexer. Okay, here is the definition of multiplexer. It's a combinational circuit which selects signals from many input lines and directs it to one output line. You know, this multiplexer is used for many to one. Means it selects from many input lines, it selects only one, and it directs it to one single output line. One output line or single output line. Many, it selects from many and sends only one. Okay, means 4 to 1 means there will be 4. It will select from 4 it will select from 4 input lines and will direct it to one output line. Like that, in case of 8 cross 1 multiplexer, it will select one signal from 8 input lines, and it will one only that selected signal will go through one output line. Okay, so this is for multiplexers are here for 4 to 1 4 many to 1. For it selects from many and directs it to 1. This is called multiplexer. Okay. So in our syllabus, we have to learn 4 cross 1 multiplexer and 8 cross 1 multiplexer. Okay, so 4 cross 1 multiplexer is here. 4 cross 1 multiplexer, it is an electronic circuit which selects a signal from 4 input lines and directs it to one output line, 4 to 1. Okay. Now, drawing circuit of 4 cross 1 multiplexer is very easy, you know. If you know how to draw, if you're going to draw the 4 cross 1 multiplexer, then if you know how to draw the 2 cross 4 decoder. So first draw the 2 cross 4 decoder. Here I'm drawing. Draw the 2 cross 4 decoder which I've taught just. So for 2 cross 4 decoder, we require one X. Okay, then Y. both with not gate line. Okay, here. Okay, 2 cross 4 decoder. Now 2 input lines, now 4 output lines, 4 AND gates. थोड़ा बड़ा बनाना पड़ेगा यहाँ पे. 4 AND gates. Okay, then first line 0 0. So 0 0 0 0. Okay, then 0 1. So 0 1. Then 1 0. So 1 0. Then 1 1. So 1 and 1. Okay, this is F0 1. You can say F1, F2, F3. Okay, so this is 2 cross 4 decoder we have designed. Now take one extra input lines from each AND gate, I0, I1, and then I2 and I3. Okay, one extra input line from each AND gate. Okay, after drawing 2 cross 4 decoder, one extra input lines, draw one extra input lines in each AND gate, and then join all the AND gates with one OR gate. Join all the AND gates with one OR gate. And this is finally your 4 cross 1 multiplexer. Again, I'm repeating, to draw the 4 cross 1 multiplexer, first draw the 2 cross 4 decoder, and then in each AND gate draw extra input lines that are I0, I1, I2, I3, and join all the AND gates with one OR gate, and by this way you can draw the 4 cross 1 multiplexer. Okay, in the same manner, if you want to draw the 8 cross 1 multiplexer, okay, in case of 8 cross 1 multiplexer, you have to draw 3 cross 8 decoders. You have to draw 3 cross 8 decoder and then do the same thing. Draw one extra input line in each and every AND gate by I0, I1, I2, I3, I4. I5, I6, I7 will be there, and join all the AND gates with one OR gate. In the same manner, you can draw the 8 cross 1 multiplexer. Okay, and in case of multiplexer, here we do not write X and Y. Here we write S0, S1. Here you can write X and Y, no problem, but S0, S1 actually, these two lines are, in case of multiplexer, these two lines are called selectors. Okay, so in case of 4 cross 1, that's why S0, S1 we are writing. Okay, selectors, S for selector, S for S0, S1. Okay, now truth table I am drawing here. So here S0 and S1 are what? Selectors. Please remember, you may have the question, okay, how many selectors are there in 4 cross 1 multiplexer? So how many selectors are there? 2. Like that, in 8 cross 1 multiplexer, there will be 3 selectors. 3 selectors. Selectors or select, whatever you want to say. Okay. So this is the circuit of 4 cross 1 multiplexer, and the logic gate diagram will be what? S0, S1. Okay. If it is 0, 0, 0, 1, 1, 0 and 1, 1. So the output Y will be, in case of 0, 0, the output I will be 0. Here 1, sorry, it will be I0, I1, I2 and I3. Okay, now I'm going to explain the working of this multiplexer. Listen carefully. When the value of S0 and S1 is 0, 0, as you remember, in case of decoder, if the value of S0 and S1 is 0, 0, only for this AND gate you will have 1, for others you will have 0. Okay, so if the value of S1 and S0 is 0, 0, so by this way, this AND gate will be selected. Means for this AND gate only will have output 1. So by, if it is 0, 0 means this AND gate will be selected for the output. So that's why they are called selectors. Okay. So if the by these input lines, the AND gate, the output line will be selected. This AND gate will be selected when the value of S0 and S1 is 1 or 0, 0. Okay. So whatever, if it is 0, 0, this AND gate will be selected, and whatever the input from this I0, if it is 0, here also the output will be 0, and if it is 1, the output will be 1 here. Means if S0 and S1 are 0, 0, the output will be I0. Whatever the value of I0, that will be the output. This is the working. Okay, so that's why S1, S0 and S1 are called selectors, because of these values, the AND gate, the output line will be selected. If it is 0, 1, consider if it is 0, 1, 0, 1. In that case, this AND gate will be selected, and whatever the value of I1, if it is 0, the output will be 0. If it is 1, output will be 1. That's why I1, I2, I3 I have written. So this is the working, and this is the logic circuit. This is the truth table of this. One more question you may have related to multiplexers sometimes, not all the time. So please read the question. It is said to draw the logic diagram, or it is said to draw the block diagram. I'm going to draw the block diagram here. Sometimes you may be asked to draw the block diagram. Here I'm drawing 4 cross 1 multiplexer. It is also called MUX. In short, we can say MUX. So here the inputs are 4 inputs are here: I0, I1, I2 and I3. Okay, 2 selectors are here, S0 and S1. These are what? Selectors. And 4 to 1, this is what? Y, that is output. Okay, inputs, these are what? Inputs, and this is what? Output. 4 to 1. So this is what? Block diagram of 4 cross 1 multiplexer. Okay, so sometimes you may have the question to draw the block diagram. So you can draw the block diagram like this. Okay, so this is all about multiplexer, 4 cross 1 multiplexer. And the same manner you can draw the 8 cross 1 multiplexer. For 8 cross 1 multiplexer, you have to draw the 3 cross 8 decoder, then one extra line, input line in each AND gate, then join all that AND gates with a one OR gate to get the final output. And S0, S1, S2, and then Y will be I0, I1, I2, I3, I4, I5, I6, I7, and here I0, I1, I2, I3, I4, I5, I6, I7, and S0, S1, S2. Three selectors will be there, S0, S1, S2, and one output there too. Okay, so please try to draw the 8x1 multiplexer. Okay, so this is all about the circuits which I have explained here. So in half adder, full adder, encoder, decoder, and multiplexer. Each and every circuit I have discussed in this video, and basically you have to learn how to draw the logic diagram and how to draw the truth table. Please learn it, prepare it. At least one circuit will be there in the examination. Try to don't just watch this video, just try to draw it yourself. Practice at least once to draw each and every circuit. Okay, so this will be very useful for you. So thank you for watching this video till end, and thank you. Bye.